Everyone. So I'm glad to have this opportunity for sharing my work about the combinative chemical analysis by functional surface nanodroplets. So here I would like to give a brief introduction about the liquid-liquid extraction. So the liquid-liquid extraction is widely used in chemical detection and sensing field, and the principle is based on the solubility difference from two immiscible liquid of the target analysis. For example, we know some chemicals is insoluble in water, but soluble in some oils. So we can use those oils to extract the chemicals from the water because the oil have higher solubility. So also the micro-sized droplets are widely used to enhance the extraction rate because when droplet is small enough, the surface area to volume ratio is very big. So here, as shown in the picture, we can see that the researchers use the dispersed microdroplet in the bulk to achieve the high extraction efficiency. But for the method, the drawback is that the centrifugation is necessary to separate those two phases, the two immiscible phases, and then other analytical chemistry instrument is necessary to analyze the extracted analysis. So try to overcome those drawbacks. We apply the surface nanodroplet in the extraction of organic acid in the oil phase. Here we showed that we can form the surface nanodroplet with color. Those color is given by the pH indicator, and the faces of the droplet is liquid. So because the surface pinned droplet, they have very long lifetime and would be very stable to allow us to achieve the in situ detection. So we would see that it will be stable if we only inject pure oil, but it will have the color change if the oil contains acids. So we also find that the time scale of the color change of the droplet depends on the droplet sizes and the concentration of the oil concentration of the acid in the oil. So this phenomena can be simply explained by the mass transfer equation I'm showing here. And after the integration of this equation, we can get the relation between the decoloration time of the droplet and the droplet size. So we also find here given sizes of the droplets and given concentration of the acid, different acid shows different decoloration time scales. So inspired by this, we tested the acid mixtures. So those acid mixtures are same in pH value, but different in the components ratio. So we find that even they are in same pH value, they shows totally different curves of the decoloration. So inspired by this, we apply our method for the detection of the counterfeit alcohol. So here we use three famous Chinese spirits. So we know Chinese spirit contains thousands of families of organic acid. So we find that those spirit has the same pH value, but by our method we can distinguish them by the different curves. Also for the same brand, we also can distinguish the cheap one and the expensive one, so which can allow us to distinguish the counterfeit alcohol. So because this our method can form different sizes of the droplet and it can be controlled. So we can form some very large droplet, even can be captured by normal smartphone camera. So we also can achieve the instrument-free method to have this detection. Yeah, that's all my talks. Thanks for listening.